Hello, this video introduces the concept of power. In previous videos we've looked at what work is, or work done by a force, which is force times distance, and just to bear in mind they're in the same direction. So I'm going upstairs, I weigh 90 kilos, I'm going up 3 meters and I'm going to have to battle against gravity. So if I walking or running, which is going to be more effort? Well, running is because we're putting in more work over a shorter period of time, yeah? So we're going to have to put in more effort. And we call this sort of effort, work over time, we call power. Let's have a look at the maths of that. Power equals work over time. And we know that work is force times distance. If we just rearrange this equation slightly to have distance divided by time here, we recognise that that's velocity. So power equals force times velocity. Units, well, that's in watts, and we see it's quite a lot in sciences. We're heating stuff up, don't we? So people can either think of that as joules per second if it's work over time, or force times velocity is newtons times meters per second. And if you expand it all out, you get kilogram meters squared per second cubed. Don't really use that very much. Okay, so let's use this as an example, going upstairs. So I've got my 90 kilos, I need to lift it up the stairs. That's a height of 3 meters against gravity, and I do that in 10 seconds. Yeah, I'm only interested in my vertical velocity because I've got my force downwards here over the gravity, which is what I'm battling. So what's the gravity force? Well, it's 90g, and my velocity is 3 over 10, which is 0.3, isn't it, meters per second. If I multiply those together, I'm putting out 265 watts. Quite often we're looking at all these steady state cases because we really don't know how some detailed like machines work at A level. So let's have a look at this. I've got a car traveling at 30 meters a second, yeah, and it's got an engine in that's creating a motive force. Don't know a lot about that. So, but what I do know is if it's running in a steady state, F equals ma, A equals 0. So this motive force must equal my resistive forces, and that's predominantly air resistance. So if we went in a wind tunnel and measured that as 5,000 newtons, then we would know that the power is the force times the velocity, and the air resistance is 5,000 newtons, the velocity is 30 meters a second, so the power output is 150,000 watts. Quite often that you'll see that written as 150 kilowatts for an engine. A bar heater with one bar, and it's about 1 kilowatt, so it's like having 150 bar heaters switched on. Another example, tube escalator. Yep, so we're going up the lift and it's lifting people up. There's 75 people on it, and it takes them up 15 meters, and it takes them 1 minute to go up. And let's assume each person weighs 60 kilos. There's no friction or anything, so all we're doing is working against gravity again. Well, so I've got to lift them up 15 meters every minute. So my velocity going vertically, because we're battling gravity, 15 divided by 60 seconds. So my velocity, what's that? 0.25 is going to be, isn't it? 0.25, yeah. It's quarter. Okay. We've got these people stood on here, isn't it? And you could think about the fact, if we were looking at a diagram, we've got 75 people and they're all spread about. But during our minute, we got some people getting on and we got some people getting off. What we could do is just consider all 75 people to be at the bottom at the start of the minute, and at the end they're at the top. Yeah, that ignores the people getting on and off, just taking one group of people from bottom to top. And what we got to do? Well, we're fighting gravity, so we need to know what the mg for this group of people is. Well, we got 75 people and they weigh 60 kilos each, so that's our mass. We're moving that mass up by mg, so we've got gravitational acceleration. So our force is going to be 75 times 60 times g, and our velocity is 15 over 60. So if we calculate that out, the power we need to put into this to keep this escalator running is 11,000 watts. That's 11 bar heaters. So there we are. That's the concept of power. Power is the rate of work. It's force times velocity. Remember, they've got to be in the same direction, particularly if we're playing around with gravity. The unit is in watts, that's joules per second or Newton meters per second. And typically in the steady state examples you're going to be looking at, because we don't understand machines particularly, and how they work, how they generate energy, power, then we'll be looking at the resistive forces times the velocity if we've got something moving along through the air, or if we're moving something vertically upwards against gravity, well, it's the mass we're moving up times gravity, that's our force, times the velocity in the upwards direction. So there you have it, power.